So today class is on Ceva's theorem. So Ceva's theorem and its application. So before going to Ceva's theorem, we discuss on some previous theorem on area. So recall this theorem on area of a triangle. So we know that area of a triangle ABC is just half of area of triangle ABC. It is the area. It's half of BC and the height. And what is height? Height is just opposite vertex A. If we draw a perpendicular on BC, at the end with the foot of the perpendicular, then we know this half of BC into AN. Sorry. So we know this. So, and now the consequence of this theorem is, if we have two triangle, say this one triangle, another triangle is like that. So now this is a ABC, one triangle is ABC, another triangle is ADE. Since the height is same for the both triangle, so what is the ratio of this two triangle? Area of the two triangle, so area ABC divided by area ADE is just half of BC into the height, say height is N is the foot of the perpendicular from A on BC, and for the triangle area of the triangle ADE is half of D into A. So that means is a ratio of two base. So this is an important theorem on area, and we will use this theorem to prove Ceva's theorem. So this is very important. So we apply this theorem several times. So there are several consequences of this theorem, like if we have two parallel lines, and we have say two different triangle like that, say ABC and say PQR. Since now AP is parallel, PA is parallel to QC, so again since PA and QC is parallel, therefore the height from height of the both triangle, that is perpendicular distance from P on BC or P on QC is same as perpendicular distance from A on QC. So that means height is same. So again the ratio is just ratio of ABC, ratio of the area of the ABC and PQR is just ratio of the base BC by QR. So we have to use this theorem. So what is the figure? The figure is like that. So consider this triangle, and we have three line segment, one from the vertex A to a point D on BC. So D is a point on BC, and we join AD. Now another is like that, say E is the point on AC and we join D. So, D is another line segment. And the third line segment is like that. So, F is point on AB and we join C and F. So, and these three lines or line segment are concurrent. So, it is concurrent at say G. This point is G. This is a common point of both of three line segments. So, G is a common point of AB, AD, BE and CF. And this is a figure. So, we now we will use that theorem, that area theorem on this several times. How we use this theorem on this? So, remember that is ABC is a triangle, D is point on BC, E is point on AC and F is point on AB, and this AD, BE and CF are concurrent and the point of concurrency is G. Now remember this is the line, yellow line, then blue, and then this from A it is white, then yellow, then blue. So, you draw the figure again. A triangle is ABC. We have this line AD, D is the point on BC. So, this is the figure, okay. So, ABC is a triangle and D is the point on BC. We join AD and take a point G on AD, any point on AD, and we join BG and CG, right. So, we have the whole triangle we divide into 4 parts. Basically, we have one triangle, then divide into 2 part, then again divide into 2 part. So, actually there are 7 triangles. So, this is one triangle, this BGD, then CGD, 2 triangles, then BAD, CAD, other 2, 4, and then ABD and ACD, 6, and the whole triangle. So, now we know the what is the ratio of these two area. So, we see that the ratio of BGD, so area of BGD divided by area of CGD, what is that? So, this is base is BD and this is base is DC, but the vertex is same. Since vertex is same, the height is same. So, half of height into base, so height cancel out, half cancel out, and then is a ratio of 2 base, right. So, it is BD divided by DC. So, this is a very important thing. So, we know this area theorem, right. Now, similarly, area ABD divided by the triangle area of the triangle ACD is same BD divided by DC, right. Just draw this triangle, same height, since it is same height, this ratio of the area is just the ratio of the base, right. Now we will use this thing. So, this is the most important part, and we will use this part several times. Now, this ratio is same as BD by DC, and this ratio also BD by DC. So, that means these two ratios same. So, from that what we can conclude? We can conclude that the area of ABD divided by area of ACD is same as area of BGD divided by area of CGD, and that is same as BD by DC, right? Clear? Now think about this. So this is like something like some ratio thing, some A by B is equal to C by D is equal to K, then what happened? So we know in algebra what happened. So if we have something, some result from algebra, so A by B is equal to C by D is equal to K, then what happened? Then what we can conclude? You know, I don't know. Actually, if A by B equal to C by D equal to K, then A minus C by B minus D is also K, right? That we can easily prove that A equal to B K, C equal to D into K, put that and it's cancelled. So now if I use this, so think this is A, this is B, this is C, this is D, and the BD by DC is K. So whole thing is K. Then using this result, what we can conclude? So we can conclude that area of ABD minus area of BGD divided by area of ACD minus area of CGD is same as BD by DC, right? ABD minus BGD divided by area of ACD minus CGD. Then what is this area? This is area of, that means this area of ABG, right? This triangle minus this triangle, AGB divided by area ACG same as BD by DC. So we use this theorem, that area theorem is twice, and we use this result from algebra. So that means we have this thing, this area of this divided by area of this is same as area of BD. So the length of BD and divided by length of DC. Right. Is it clear? Now we use this thing three times. So now one more figure. Same figure, same ABD, ABC, same triangle. Now we extend this part, right, and G is the same point. We just draw up to this, not full, right, and we draw that AG, not the full. So this is G, and say this is E. So we have a new point. So we extend BG and it meets AC at E, right? And we just erase this part, that GD part. Then if I use this thing, same thing on this triangle, then this triangle, this four triangle, what we will get? The same thing, it's just figured like that. What we will get? Similar way, that area of BC, not BC, right, BCG. So similarly, area of BCG, that is area of BCE minus that GCE, same thing, divided by area of we call BAG side, BAG is same as CE divided by EA, right. Now the last figure, this yellow line complete, white line complete, I will complete the blue line. So A, B, C, now complete this line, CF, now take this point as F, and then that yellow line BG and that white line A. Clear? So similarly what we get? Triangle, similarly this, and we get area of the triangle AG or ACG divided by BCG is same as AF by FB. So we will write like that, BD, DC, CE, EA, AF, FB, like some clockwise thing, or sorry, same sense, anti-clockwise. Is this clear? So we just write down this figure. Now we will compile this, all these three, right. So we have three results, 1, 2 and 3. So same figure actually. In this figure we didn't write draw this part, not this part, this part. Actually now we will draw all parts. Actually is seen the previous thing. So this is actual the whole thing. Okay, this part. So this figure is the complete figure. Now again draw the complete figure. Triangle ABC. Now we draw the whole line CF. Then the white part AD, and there is the yellow part BE, and this common point is the point of concurrency G. So AB, AD, BE and CF are concurrent, and concurrent at G. Now D, E, F can be any point, not any point, such that these are concurrent. So you can choose D, E, then the F is unique way we can find. If we just find, say D, we choose D here, F here, then for every D and E pair we have a fixed F, right. So 3 point we can't choose, we can choose 2 points, and then third point is automatically defined because this is our concurrent, right. Now we compile all these three. So what we will get? A, what is BD by DC? ABG, area of ABG divided by area of ACG say same thing. Now C in the same sense, C by EA, what is that? Area, no, not AGB, it is just B, this part, no? Oh sorry, this, so it is B, why, no, this is EC, so it is BCG, BCG divided by EA, so it is, now it is ABG, right? Now the last thing, AF divided by FB. So now it is ACG, area of ACG divided by area BCG. Now if you multiply all these three things, what will you get? BD divided by DC into C by EA into AF by FB is what? Just check it. This into this into this. So BCG is in numerator, BCG is in denominator. So cancel out. ABG is denominator, ABG in numerator, cancel out. ACG cancel out. So everything cancel out. It is just. So if you take this same sense, and the ratio of the product of the all three ratios, this is just 1. And this is a renowned theorem, is called Ceva's theorem. Oh, so please explain the. Oh, yeah. So I'll explain the this. I'll give some application. I show some application of this theorem. So this theorem is very important. It's called Ceva's theorem. Okay. So before going to the converse of that, I'll show the converse. I give just one application first. Okay. As someone asked, what is the purpose of this theorem? So is this clear? Ceva's theorem is clear. So important part is the 3 line segment must be concurrent, and I will show if it is not concurrent, then product is not 1. Converse is also true. So is concurrent, then product is 1, and if product is 1, then it is concurrent. So before prove it, I will show one application of that. There are several applications. So first application is like that. ABC is a triangle, and that DEF are the special points. Say this is a midpoint. D is a midpoint of BC. E is the midpoint of AC. This is a midpoint, and sorry, and they meet at G. So D is the midpoint of BC, E is the midpoint of AE. That means BD is same as DC and CE is same as AE. Clear? Right. Now we join C, G and extend and meet at say F. So what is our construction? We construct like that. We join CG and extend up to F, where F is a point on AB, right? So we know D is the midpoint of BC, we know E is the midpoint of BC. We do not know about this F point, right? But they are concurrent, right? So since they are concurrent, what happened? We know this product of the ratios are 1. So that means BD by DC, actually this is 1 because this is a midpoint, into CE by EA, this is also 1 because E is the midpoint, into multiplied by AF by FB is 1. Why it is 1? Because they are concurrent. We already proved. We already proved that if this lines are AD, BE and CF are concurrent, then the 3 ratio product is 1. So that is why is 1, and this is all BD by this is 1 since D is the midpoint. C by EA is also 1 because E is the midpoint of AC. That means these 3 things, what we get from that, AF by FB is 1. That means AF equal to FB, that means FB is the also midpoint. So that means the you know that AD is called the median and B is also median and CF also median. So if there are 2 median, if we joined that intersecting point G to C and extend, and that meet the AB at midpoint. So that means the all 3 medians are concurrent. We know this proof in a different way in the book, but using Ceva's theorem is just a one line proof, right. So this is the answer why this what is the purpose of this theorem. So I will show one more, just draw this figure. We will show one more application of that. So now it is some construction problem. It is very interesting construction problem. So we have 2 lines, 2 are parallel, then say AB and CD, 2 lines are there, actual line segment given, you can just extend this line and you have to find the midpoint of AB. So this is a problem. So we can always find the midpoint of AB. How do you get midpoint? We just take the compass and then take an arc with some radius here and in the below the AB, above AB, same arc length, same radius from B, intersect 2 part and join. This is, we know this is a perpendicular bisector, but we are not just drawing the perpendicular bisector, we just need the midpoint, not the perpendicular. Just find the midpoint, but without using compass. If I just have only pencil and that's ruler, ruler, straight edge, there is no marking, actually not a scale, this is just a ruler, straight edge, that means there is no marking, you have to find the midpoint. How do you find the midpoint? So this is you have to find the midpoint of AB or midpoint of CD, is given that these 2 lines are parallel, this is given to you. Actually we have just only straight edge, right. So you can draw lines, we can't draw arc because there is no compass. So we can just join, right. We can't do anything, so we have to join. We can do only this thing. So we can join, we can extend, we can draw a line. So okay, join AC and then extend, then join what, BD and then extend, right. Say meet at some P, then we just join, we can join just then which point you want to join? Something, you can just no need of joining now AP, right, you just joined AD now, and then you get a new point, say G, then next we can join P and G, right. And if we join P and G, say this is say E, now we have a triangle and these concurrent lines are there, right. So using Ceva's theorem, what happened? A ratio. So what is the ratio? So AE divided by EB into BD divided by DP into PC divided by CA is 1, that you know. So, that is the application of the Ceva's theorem. Now, just we have to prove A is the midpoint, we guess, right? We do not know, there is no other point, we can't find no other point, okay. So, we can just find this way only. So, my guess is just E must be the midpoint. So, that means we have to prove AE by EB is 1. That means you need to prove this part is 1. So, is this part is 1? Now, there are two triangles, similar triangle, right? Since this CD and AB is parallel, we have two similar triangles. So, triangle APB is similar. This is a similar sign of similar. A, no, C, not A. It is CPD. So, this triangle is similar to this triangle because this angle is same as this part and this angle is same as this and this is a common. Now, since this is similar, we know the ratio must be equal two sides. So, this is what? PC by what? PA. Okay, just we write in the reverse opposite way. Some AP by CP PC is equal to PB or BP by PD. We write it as a DP, so it is DP. So, it is just from similarity. Now, take just add -1 in the both side. This is very similar. Now, AP by PC -1 is same as BP by DP -1. So, what will get? AP minus PC by PC is same as DP minus BP minus DP by DP. So, what is AP minus PC? It is just CA. So, CA by PC into is equal to, we write is BD. So, BD by DP. Now, whatever. Now, it is just side change. It is CA PC, right? So, it is CA. So, CA and BD are equal. So, no, is there anything whatever CA by C? Yes, BD by DP is CA by PC, so it is cancelled out. It is becoming 1. This product is become 1. So, BD by DP into, just go that side, PC by CA is equal to 1, right? So, that means this part is 1, and since this part is 1, so this from this and this from 1 and 2 we get AE by EB is 1, that means E is the midpoint. So, this is the proof, okay. It's clear. So, this is the one application of construction of midpoint without using compass, but we need one parallel line. If I just give one line and I ask that find the midpoint without using compass, we can't do. Okay. So, we need one parallel line, but the proof is using Ceva's theorem. We will show one or two more application of the Ceva's theorem. Now, we will first prove that converse. So, what is the converse? Now, ABC is a triangle, draw a line ADD is a point on BC, draw another line BE is a point on AC, And one more line, CF. Now we do not know whether it is concurrent or not, we do not know, just any 3 lines, any 3 line segment, okay, we do not know concurrent. But we know that it is given to us that BD by DC into CE by EA to AF by FB is 1, that is given. So in Ceva's theorem we have to show this, given that it is concurrent. Now it is given that its product is 1, prove that now it is concurrent. So that is a converse. So, and we know in every geometry theorems, several geometry theorems has the converse, and the technique of proving of the converse is we have to use the previous theorem actually. The main theorem, using that main theorem we want to prove the converse. So we have to use the previous Ceva's theorem. How do you use this Ceva's theorem? Just we draw a line, we draw another line, right, which is concurrent. Say this point is say G, and join AG and R is on DC, BC, right. So now we can use Ceva's theorem on, not on AD, it is on AR, BE and CF, right. And if I use Ceva's theorem for 3 line segment AR, BE and CF, what we will get? BR by RC into CE by EA into AF by FB is equal to 1. This is by Ceva's theorem. This is given and this is by Ceva's theorem. It's clear? What we have to show? These are concurrent. So what is, now we have to show that this line actually AD is same as AR. That we will show. So that means what we have to show, D and R is same. If we can show D and R are the same, be the same point, D actually equal to R, then done. Because if D equal to R, then AD is same as AR. So that means AD, BE and CF concurrent. So we have to show that D and R is the same point. So from these two, given condition and Ceva's theorem, what we get? This part is same, C by ES, this part is same, right. So from these two we get BD by DC is same as BR by RC, because just this will be go that side, this will be go that side, these two are same actually. So from this can we prove that D and R is same? Okay, now this figure is already the importance of this figure is over. So we just, this line is important. So we draw this line again. That line and the points are B, D, R and C, and just take BD as A. This part is A, this part say B. So BD, let BD is equal to A, DC is equal to B, and then BR is equal to X, and this RC is equal to Y. So what we already proved? We prove A by B is same as x by y. We already proved it. What we have to show? D and R is same. That means we have to show A equal to x and B is equal to y. B equal to y and x equal to A, then D and R the same. So how do you prove that? The ratio of this is same, but we do not know whether the numerator is same as the numerator. Like 10 by 2 is 5 and 20 by 4 also 5. So we can't say 10 equal to 20. So, but there is one more extra thing, right? This is A, this is B, this is X, this is Y. So what is the extra part? What is the one more relation is there? This part is A, this is B, this is X, this is Y. So one more extra relation is there. What? BD is A, DC is B, BR is X and RC is Y. So one more extra condition is there. Not my what minus what? Right, very good. So X plus Y is equal to A plus B. Now we can easily show that. So we add 1 to the both side. A plus B by B is same as X plus Y by Y, but A plus B is same as X plus Y. That means B is equal to Y. And since B equal to Y, A is equal to X. Right? So these are converse of the Ceva's theorem. So Ceva's theorem has several applications. So some theorems we already proved in class 9 or 10 using some several steps, but using Ceva's theorem it is just 1 or 2 line proof. I will show one more. Next we will prove that in center thing. So by the way that if I join all this median, then the point is called centroid. The point of concurrency is called centroid. Now we will show that all 3 angle bisector are also concurrent, and that is called incent, right? So next slide. So before going to the angle bisector part, we need one theorem I already discussed in the previous class, that angle bisector theorem. You know this angle bisector theorem? Recall? What is the angle bisector theorem? If this AD is the angle bisector of the angle A, sorry, these two angles are equal. So this angle bisector BAD is CAD. Now this is angle bisector. Then what happened? You know any result on that? Similarities. How do you find the similar triangle? Actually, you have to draw the perpendicular from B to AD, B from B on AD, and from C on AD, and then we have some 2 more this thing. So now this triangle and this triangle is similar, and again this triangle and this triangle is similar. So from that we can easily show that AB by AC is same as BD, this point is D, by DC. So the angle bisector divides the opposite side the same ratio as the 2 sides, corresponding sides. That you can easily prove that this divided by this is by the using these 2 similarity, we have this divided by this, and again these 2 triangle similarity, this divided by this is same as BD by DC, right? So now we will use this thing. So if I use this thing to all 3 angle bisector, we do not know whether they are concurrent or not, we do not know. A, B, C, D, E, F, this angle equal to this angle, this angle equal to this angle, and this and this. Now we don't know whether it is concurrent, we have to prove that this is concurrent, right. How do you prove that concurrent? Same thing, BD by DC, what is BD by DC? We already proved that angle bisector theorem is AB by AC. Now what is C by EA? C by EA, it is BC by AB, right. And the last one is what is AF by FB is just AC by BC, right. Now if you multiply all these three, what happen? What about the BD by DC into C by EA? Huh? BD by DC into C by EA to AF by FB. Just again AB cancel out, AC cancel out, and BC, so it is 1. Now since the product of the three ratio is 1, we already proved that using the converse of the Ceva's theorem they are concurrent. There are other proof also, but these are using Ceva's theorem. So 2 proof and 2 theorems and 1 construction. Now can I now, so it is called in center, right, that angle bisector meets at in center. Now can I, there are actually 4 points in triangle, the medians are concurrent and that is called centroid, the point of concurrency. The in center angle bisectors are concurrent and that means point of concurrence is in center. There are 2 more, what? Perpendicular bisectors are also concurrent, the point of concurrence is called circumcenter, and the altitude, that height from the point, they are also concurrent and this is called orthocenter, right. Now the problem with this circumcenter is this, there is actually we need some line from ABC, but now perpendicular bisector is the figure like that, right. So these lines are not that Ceva's lines, the Ceva's theorem lines. This line has some name. If for a triangle ABC, take any point on BC and join AD, you can do the same way, same thing with take a point on AC and join B with that. This line has a name that AD is known as, since it is very important for Ceva's theorem, it is called Cevian. From Ceva it is Cevian. Cevian means as a line from a vertex to a point on the opposite sides, but the problem is these lines are not Cevian, right, these lines are not Cevian. So the idea is actually you have to draw one bigger triangle, right. If you have a bigger triangle and that bigger triangle, maybe these lines are Cevian. That is the one way to prove that. Now before discuss on this that is called circumcenter, we have this theme, altitude, right. ABC, and we draw the altitude. N is the perpendicular from A on BC and N is the foot of the perpendicular. CF, similarly CF is the altitude, B is also altitude. We have to prove that these 3 altitude are concurrent. Now they are Cevian, right. So how do you prove that? So to prove it is concurrent, what you have to show? So to show okay, we name it as D. For the sake of notation, we name it as D. That AD CF and B are concurrent, we have to show what we have to show? The ratio of the product of three ratios is 1. That BD by DC into CE by EA into AF by FB is 1. Can we prove it? It is 1. So not sorry, not it is BC, it is BD, right? BD by DC, CA, right? Now we don't know whether what is the ratio of this in for median. We know the ratio is something 1, and for angle by theta the ratio is same as this ratio. But can you do you find anything is on that using some sine theta or like that? Sin, no, not sine, just using sine theta cos sine B. What is sine B? Sine B. No, sine B is okay. No, not don't not no. Use this thing, this angle. So what is sine of that angle? Sine of what angle? Angle BAD is BD by AB. So AB will work, right? So everything everywhere some AB will be there. Huh? BAD, sorry. So we have this BD. What about DC? We have to take which angle? Sine of, okay, or CAD, right? CAD DC by AC, right? What about this? We got this BD, we have this BC, DC, and then C. What is C? Sine, which we need this one. Okay, we just write some name here. Say alpha. Then which angle? Okay, this is alpha. Then what is alpha? This is also alpha, right? Because this is 90° minus B angle, and this is right angle. So this is alpha. Next, we say this is alpha. Then say this is beta. Then which one is beta? Which one? This is beta, right? This is the complementary angle of A. Now the last one is gamma. So gamma and this is gamma. So we can write this as sine alpha, right? And this is sine beta. Not CAD. It is CAD. DC by, yeah, CAD is gamma. Sine gamma. Now what about this? Now we need C by BC, right? C by BC. So what is C by BC? Sine gamma, right? What? Now, is there something alpha gamma beta, right? That is the CE. These are hypotenuse, right? So that is sine gamma, right? Sine gamma. And what is EA? What about EA? EA by what you need? EA by AB is EA by AB is sine beta. Two more, that AF. What is AF by AC, right? AF by AC is sine beta. And last one, that FB. FB by FB by BC is sine alpha, right? Now replace everything there. So BD is replaced by what? AB into sine alpha. So AB sine alpha divided by what? What is DC? AC sine gamma into what is C? BC sine gamma. It is sine gamma, no? Last one. DC is gamma. By EA AB sine beta. What is AF? AC sine beta. And last one is FB. BC, is it what? AC, AB, BC, BC, and sine alpha, sine beta. So it's, this product is 1, and since this product is 1, they are concurrent. So not the direct thing, you have to use some sign, not sign rule, it is just the sign form, just definition of sign. But the last one, that circumcenter, is slightly tough. So because there is no CVN. Okay, so just write this. It's clear? Is there any question who are in online? So Ceva's theorem has very good applications, and this theorem is very interesting. Now we will show one more similar type of theorem, which is not that much useful of, as Ceva's theorem, but is also interesting and useful. So it is called Menelaus theorem. Now here it is concurrency thing, where the is collinearity. So concurrency and collinearity are very important concept in geometry, you know that. So should I go in the next slide? Okay. Now the Menelaus theorem. Menelaus. Okay. So now again there is a triangle ABC. Now in the previous Ceva's theorem we choose 3 line segments which are concurrent. Now we will choose 3 points which are called collinear. So now we have to extend this part. Now choose 3 different points on AB, AC and BC. Say these 3 points. So this is D, opposite to the B is E. This is I will not give the proof of this theorem. So what is the Menelaus theorem? If F, E and D are collinear, or D, E, F are collinear, then same thing, the ratio is something BC by CD into what? BC by C, same thing, C by EA into AF by FB. Now sometimes it is write minus 1. Why is write minus 1? Because actually, oh sorry, it is BD, sorry. So BD, because in the Ceva's theorem D is the here, so BD by DC, so BD by DC. Now why it is called minus 1? Because actually we go in the same direction, BC in the Ceva's theorem BD then DC, same direction, C EA, F FB, now it is opposite direction, BD DC, one opposite direction is there, but okay, these are the same direction, that is why you call minus 1. Actually it is 1 in the in line segment, it is 1. If you just find the length, it is 1. We just write minus 1 because of this opposite, like a vector notation. Like you know, in coordinate geometry, if it is a divide outside the line, the point is outside the AB, then it is the ratio is something called minus, right? You know that. So if AB, now it is D, C is the midpoint, then we say AC is to CB is say 1:1, right? But we call say AC by BC, sorry, or AB by BC, say. Now AB by BC, so this is to this is, we call it is minus 2:1, right? In coordinate geometry, because B is the external point, something like that. So it is AB, then it is backward, so opposite direction, that is why it is minus. You can just write as 1, okay. Just if you measure the length, find the length, and its product will be 1, not the minus 1. Minus 1 for this direction, and if you find the coordinates thing, and then we will find why it is minus 1. Otherwise in geometry it is just, it will give 1. So these are Menelaus theorem, and the converse also true. If this is product is 1 or whatever, you can say it is minus 1, then these 3 points are collinear. And this have a one more application construction of that. I will not give the proof, it is homework. It is slightly tough. Like that, say there is a say in your paper, this part you can't draw any line on this part. This region you can't draw anything. Okay. Now problem is, say there is a point A here and there is a point B here, and you have to join A and B. You have to join A and B, but you can't put your straight edge here. You have to go outside, then this, right? So okay, what do you mean by that line joining? Obviously you can't join this line, actually you have to find 2 points here. If we join this line, actually you have to find these 2 points, right? So nothing is there. hypothetical point line. So, you need to find this C and D, such as AC and BC, BD is collinear, so same line, but you can't put your A and B is given to us, C and D we have to find, but no what no you can't draw anything here. Okay. Now the thing is you can't use compass also. If you can use compass, then easily you can do this. Okay. Now there is a construction is a slightly tough, and the proof will be the proof is we have to use the Menelaus theorem. Okay. So this type of construction is in some Olympiad, this type of construction will be there, some construction, unknown construction. So will be there. So okay. So one more construction I will show you that. Okay. So there is a triangle, and you have to draw the angle bisector of B. So construct angle bisector of B angle. We know how to construct that. From B we have to draw arc, the same radius, or maybe you can take the different radius from this point, right, and this point. The problem is you can't draw any straight line or anything in this region. You have to draw the angle bisector of B, but B is the point B is just gone. Say there is a page and this part is we just take away from this. So how to draw the angle bisector of B? Means you need 2 points on the angle bisector here, not this side. So hypothetically there is angle bisector, right? There is angle bisector. This dotted part means there is no such line there, right? Just a minute. You have to find this point, or maybe any point here, say D and E. You have to find 2 points. Actually we need 1 point because B point is there always, but now the B point is gone. So we need 2 points on the angle bisector, but 2 points outside this region. Very good. So done, half done. Very good. What you say that we draw what we draw angle bisector of A. Okay, remember this D is not there. Okay, D is not there. D is not there. We draw angle bisector of A. We can easily draw this, right? And we can draw angle bisector of C and say they meet at somewhere, some E. So we have 1 point because we know that E point is actually on where? Angle bisector of B. So we got 1 point. How do you get the second point? We need 1 more point because B is not there. So to find the line we need 2 points. No. To prove something we need Menelaus, Ceva's, but you first find that construction, right? To prove it, why it is angle bisector, we need something. Menelaus said the theorems need for proofs, but you first find the construction. Still we did not get this. How do you get second point? So idea is just extend this. and take 2 more point, some P and Q. Do the same thing. Angle bisector of P and angle bisector of Q. And this point is called F or D, whatever, and that point is also on the angle bisector of B. So then join BC. So the basic idea is to find some line. So say perpendicular bisector or angle bisector. We need actually 2 points. To find a line, we need 2 points, right? So if I get 1 point, the other point is a similar way you can find. Like say perpendicular bisector. How do you find the perpendicular bisector? So you need 2 points on the perpendicular bisector, right? So always we can find how. So draw an arc from here, draw another arc from here, right? And then join. By the way, this arc must be the same length, same radius, and these two are same radius, right? And this point must be on the perpendicular bisector. You know that this point is on the perpendicular bisector. Why this point on the perpendicular bisector? How do you prove this point on the perpendicular bisector? Say AB is the line segment. We draw a arc from A and draw an arc from B with the same radius. They say meet at say it is P, and you have to prove that P is on the perpendicular bisector. No. How do you prove the P on the perpendicular bisector of AB? There is 2 ways to prove it. Say drop a perpendicular and prove that is the midpoint. The foot of the perpendicular is midpoint. This is the one way. Or we can join the midpoint with P and prove it is perpendicular. So just take the midpoint D and join PD and prove it is perpendicular. And proving perpendicular is very easy because it is midpoint. So this equal to this. So SSS. And if you drop the perpendicular then RHS. So that means P is on the perpendicular bisector. We need one more point. How do you find the one more point? Same way. How? One more point on the perpendicular bisector. Because otherwise, how do you find the line? We prove it is on the perpendicular bisector. We don't know whether the D point is there. Where? Another radius. So in books, we actually here's the opposite side with the same radius, but we can do in the same side also with a different radius. With a different radius, we draw another line. So you get and join PQ. So that is the idea. To find perpendicular bisector or angle bisector or whatever, you need 2 points. Maybe one point is fixed. You have to find that one point, another point. And if we can find one point, similarly we can find actually 2 points. Right? This is the basic idea. Now I will show some other construction. So construction like that. So we know if 3 line segment is given, we know how to find the triangle, construct the triangle with this thing, that we know. That already we know. Draw the line segment, then. Now the question is, okay, we know this also, no? Some length is A, B, C, and you have to draw you have to construct this triangle with ABC. One more thing is, we have a angle here theta and 2 lines A and 2 line segment, sorry, and you have to find this triangle with A, B and angle theta. How do you construct this? Same thing, we draw a line and then cut this B length here, then draw the same angle. You know how to replicate this angle somewhere, and then theta, and then find A, cut up to A, then join this, right? That you know is actually side angle side. Similarly, if we give something like that, 2 angles is given, say theta and phi, and one side is given to us. Then what we have to construct? We have to construct this triangle with one side is A and this is theta and this is phi. How do you draw this? Same thing, you just take any line, cut this length and then form this point, we draw replicate this angle here, from replicate join this. Now the question is, we have this angle theta and this angle phi, okay, this two angle is given, but this side is not given. What is given to us? That A plus B plus C is given to us, that perimeter is given to us. Then how do you construct this triangle? How do you construct this triangle? Now you do not know what is A. Is there any idea? This is one construction, actually unknown construction, like unknown theorems. So in book there are some theorems and we have to prove some other theorem out of the book, right? The theorem is proven in exercise. Like construction also, actually in our textbook there is no such thing. The construction is given to us and that is in the exam, but maybe in Olympiad or somewhere a new construction can be there. New construction, we do not know the construction, no, like that, and maybe other construction also. How do you construct then? To prove some new theorem is tough, but prove something, draw some new construction is very tough because we do not know how to prove, how to draw, and then we have to prove why this is work. Two part. No, you can prove using ratios and others, but what is the construction? You have to construct this thing with your straight edge and pencil, compass. You have to first construct, then you have to prove why it is ABC and other thing. How? No, how, there is no length is given. Actually, this nothing is given. 60 degree, 90 degree, 45, 4 length 4. This is not given. There's some angle is draw and given to us. Okay, draw this angle. Arbitrary. We don't know what is the measure of this. Maybe 62.5 degree, maybe whatever. You can't measure this. There is no. You can't use that scale or that to measure some angle. No. We have to. We can't assume. Angle is given to us. You have to draw this triangle with this angle only. There is no protector, no scale. But we can replicate. We can replicate the angle. We know how to replicate using compass and straight edge. Any idea? No idea basically, because we are not accustomed with this type of problem. New construction, right? The basic concept is that. So to construct something, you assume that we already have this construction. Okay, this is the basic idea. So assume that this already construct. We already construct. We don't know how to construct, but we already construct. And obviously that A, B, C is not given. What is given? A plus B plus C. So now actually we do this like this, different color. Right? We don't know, say we have some stick with length A plus B plus C, and we have to break this in 3 parts, right? ABC, but we don't know where we have to break. If we can break anywhere, but then this triangle will be, the perimeter will be A plus B plus C, but angle will be not the same as what is given to us. That also you have to take care. So that means if you have this length, you can just same length here on the same line BC. So this point is say E, and this is say F. These two line segment is equal, and these two line segment is equal, are equal. Then what is given to us? That F and E, these 2 point is given to us. because we know the whole length a plus b plus c, right? We know a plus b plus c, we know this thing, we know that f e, but we do not know whether the b and c point will be there. We can't take any point. Okay, you can say c is here or b is here, no, because that this two angle is given to us, right? This two angle is given to us. So if I break somewhere here, and if I just fold and join, that angle should not be or not equal to theta or phi, right? So, but ultimate figure will be this. We have a point and e point, that we know, but we do not know where b, c and a. So, but we are just try to reach to this figure. So, the idea is to construct something, we just first draw the figure. After construction, what will be the total diagram, we have to first draw this diagram. So, our target to reach that diagram. Okay, we do not know a, but still we can join these two, right? We do not know whether a, but we can join hypothetically. Still, we have only just E and F, no other lines are there actually, no other points. We know only where E and F are, but we do not know where B, C, these lines are, others, A, whatever. But this angle is phi, then what is this angle? What? Sum of two interior angle must be? No, sum of two interior angle is the same as the exterior angle, opposite exterior angle. So then what is the angle? Well, can't be phi. This plus this equal to phi, right? These two angles are equal, you don't know? This side, these two sides are equal. That means it is pi by 2. These two angles are equal. Angle CABE and CEA same because C equal to AC. So phi by 2, phi by 2. Similarly, this is theta by 2, theta by 2, right? We have this angle phi and theta. Can I find theta by 2 and phi by 2 from there? Yes, we know how to bisect an angle, that we know. That we know, you know that first one and then two other arcs and join. So draw the angle bisector of these two. Now we know this C point, right? E point. We know this F point. We know FE. That length is given to us. Now construct that phi by 2, replicate the phi by 2 here. Not clear? First draw the phi by 2, theta by 2, replicate theta by phi by 2 at E, replicate theta by 2 at F. Now we got this line and this line also. Where they meet, that is A. Now we got this point A. Next step, to find the point B and C, we need the triangle, right? How do you get to point A? So the idea is this is A plus B plus C, this is given to us, say 10 centimeter, theta is there, from theta we draw the angle theta by 2, then replicate the angle here, phi is here and draw phi by 2, sorry phi, and then replicate here, and this is the A point, right? Now we need B and C. How do you get B and C? Same idea, you have to replicate theta by 2 here now. Here draw the theta by 2. Here you draw the 5 by 2. Done. This is your B, this is your C. How do you prove it is our the just required construction? It's clear because this angle is theta, because this is 3 by 3 by 2 and these two are same, right, and these two are same, and this is 5 by 2 5 by 2, so this is phi. We have this two theta and phi, and since and this plus this is same as this plus this plus this, that is given to us. So got this idea? So we have to first draw the diagram after the construction. Draw just by hand, not by stated and that compass. Don't use this. It's just by hand. Draw this by hand. This is your target figure. Now find the properties of this figure, and after some time you will find some properties which will help you to construct the figure. Then you have to construct using your compass and line, straight edge. Actually, no need of just drawing this. In exam, they will ask the just what is called your just drawing procedure. No need of drawing actually. You can draw by hand. In your exam, you have to construction. You have to draw using your compass and straight edge or pencil, right? But in actual exam, actually the Olympiad or other, they were ask you to draw these using compass, or that is like a drawing class. You have to state all the steps, step 1, step 2, step 3, step 4, this is all my steps. No need of drawing using compass, no compass is needed. Okay, you have to find the step 1, step 2, step 3, your all steps, and then you have to prove why these steps work. And you have to give a diagram. Obviously, you have to give a diagram, but by freehand diagram, right? No, this may not be 5 by 2, but you have to say this is 5 by 2. Okay, I draw this 5 by 2 here, but actually this may not be 5 by 2. Actual measurement. Okay. So this type of construction may ask you in this type of this Olympiad type exam or like that. Okay. So Ceva's theorem and this Menelaus theorem, these are several applications on this construction, and to new construction, and to prove that construction, why this construction work, we actually need the Ceva or others theorem. So I will give one problem to you. This is also very important. Actually, I think in the next class I will go to the circle, but since there is some time, I go into circle today. This circle, you know, what is the definition of circle? There is some curved figure, right? What is there is a fixed point somewhere, and that point is called center. And what is the property of the center? From center, if we join any line, any point on the this is called circumference. Circumference. So this is O and this is any point A. If another point say B, if you take another point say C, then OA, OB, OC, whatever point you take on this perimeter or circumference, what you say, the distance from center. By the way, the center is not the part of the circle. It is inside the circle. The radius also not the part of the circle. Only this circumference is the part of the circle. That is the circle. Sometimes we ask what is the area of the circle. Actually, nothing is area of the circle. A circle is just this line. So we can say what is the length of this perimeter circumference. It's 2 pi r. But when you ask what is the area, that means the area of the interior. And sometimes if you just consider the interior also, this is called disk. Disk means the outside circle and inside also there. It's complete in the disk. So area of the disk actually. If I ask what is the area, if pi r square is not the area of the circle, it is area of the disk, interior also. Now the most important theorem, I think it is most important theorem. There are several theorems on in circle. It's called the power of the point. Power of a point. Of a point with respect to a circle. So, a circle is given to us and a point is given to us, and what is the power of the point? A circle, and there is outside a point, maybe inside, I just draw the point on outside, say P, and one more point say inside, maybe on the circle. Three different cases: outside the circle, inside the circle, and what is power of the point? What is the definition of the power? This is right, it is positive, it is negative, it is 0, you know that. So, what is the power of the point of P with respect to this circle? That is, you have to draw a line from P, any line, you can draw any line, okay, and cut say A and B. Then power of point P with is a abbreviation for with respect to WRT, W dot R dot T, with respect to the circle, say this circle is called big C. So with respect to circle C is PA into PB. Okay. Now question, we draw one chord, actually a chord, extended chord. One can draw another chord, right? Say D and E. Then by definition, power of the point is PD into P. Now, if PA into PB is different from PD into P, then there is a problem. Which power of the point is which one? Is PA into PB or PD into PE? Actually, they are equal. So, we have to prove that these two are equal. Once we prove these two are equal, then this definition is correct, or it is called well defined. If these two are different, then definition is not well defined. For different chord, different power. So, for the same point, how can the power will be different? So, same point power will be same, otherwise the definition is not good, but definition is not well defined. We can't define like power of the point. So, to define a power of the point like PA into PB, we must show, if we take one other chord like ED, such that ED P are collinear, then PD into PE must be PA into PB. So, that proof we need to prove this, right. What about for inside point? What about for this, say on this? So, again you have to draw a chord. So, you have to draw a chord. And you can draw any other chord, any, or ST, T or whatever. What is the power of the point? Now, the RS into RR, so it is 0, RT into RR, so whatever this 0. So, for on this point on the circle it is 0, and it is easy to prove everything will be 0. But for outside and for inside, I draw another figure for inside. So, it is Q. Now, this is Q, this is A, this is B, this is C, this is D. So, power of the point is power of Q with respect to this circle is AQ into BQ, or it is QC into QD, whatever. It is AQ into BQ, or this is same as QC into QD or DQ. Okay. So we need to prove that, and this is the power of the point, this or this two are same. Okay, and sometimes it's called negative because it's the opposite direction, AQ BQ, that's why, but this is the same direction. So, and this power of the point has several applications. I will show in the next class, circle, how we use power of the point on some problem. If you use power of the point, then this point, this theorem or proof will be very easy. If you do not use, then it will be slightly hard or longer proof. So, I will end this lecture with just using this after proving these two things. So, how do you prove that these two are equal, this product are equal? So, first for the inside, okay. Say this is P, we just change our name, okay. So, we have to prove AP into PB is same as PC into PD, or AP into PB is same as CP into PD. So, we must join this, right? We must join AD and now which angle equal to which angle? Right, this angle same as this angle, and this two angle also same, because we know the same arc has the same, that is vertically opposite, that must be equal without anything, is vertically opposite, so they are equal. And why this angle are equal, we know this, because why this two angle are equal, this angle is same as this angle, why these two angles are equal? Actually, we this is half of the, actually is half of the, so half of the angle subtended at center, right? O, if this is theta, then this is 2 theta. You know the proof? You know this, right? So how do you prove this? Join this, right? Okay, I'll discuss on the next class. Actually, for class 9 student, they may not know this thing. Okay, so I'll discuss on the next class why this this is double of that, and since it is double of that, and if you have another angle here, this also double of this is, so this angle is same for this and this is double for this, double of this angle, this double of this angle, so these two are equal. So this is a theta, then this is also theta, this is phi, then this is phi. Now these two are similar, and since similar, then what are the ratios will be equal? Which of the ratios? This theta opposite to the theta, so AP opposite of phi by PD is equal to opposite to the theta CP by opposite of phi PB. Done. That means AP into PB is same as CP into PD. Just one line proof using similarity. And for the outside point, same thing, like A, B, P and C, D. Which two triangles are similar? Now which angles are equal? This angle same as this angle, and this is a common angle, right? Then A DP is similar to triangle CBP. So from that what we get? So this is theta, this is common angle phi. Now opposite to the theta, right? PD divided by opposite to the phi. So opposite to phi AD, right? Then is equal to, now this triangle opposite to theta, no, so opposite to theta, so it is BP, opposite of phi BC, but that BC and AD we no need, no need of BC and AD. Then we need that AB. We have this BP, we have this PD, we need CD and AB. How do you get CD and AD? CD and AB? So this angle also equal, no? Since two angles are equal, third angle is also equal, right? This 180 degree minus theta minus phi. Now, so this is actually one more equation is there. So, okay, we write in the other way. So, opposite to the theta is PD, opposite theta is PD divided by opposite of theta is BP. That we need, and this is equal to what? Opposite to the phi AD and opposite to the phi is BC, right? And the last thing, opposite to the this AP and opposite this angle is CP. Now AD by BC is same as, right, AD by BC is same as what? We need one more triangle, right? Need this triangle also. We have to draw this triangle, right? We have to join this, right? BD. AC is not needed, I think. We join BD. In joining BD, what we get? Right. Now these two triangle ABD and CBD, you have to join this one, what? So this angle equal to this angle, okay, you just take as a homework and do it in home. I will give one other proof of that using Pythagoras theorem. Okay, you just take the similarity of some triangle you will find this, it's not tough. So say one more proof for this one is not in the book actually, that we give using the Pythagoras theorem. Okay. So the proof is like that. So this is P, this is A, and this is B. Now take the center O, drop the perpendicular on AB, right? And you know that, if you draw the perpendicular, then BN is same as AN, right? Is a midpoint. Because if we join BO and OA, these two are congruent because BO equal to OA and this is 90 degree, this is a common side. So RHS. Now what is PA into PB? Now say this is called X, this is called D, AP is equal to D, and AN is equal to X equal to BN. Then what is PA? Okay, we call not, is called not D, say we say PN is D, say. So this is D minus X, right? The whole Pn is D. Now what is Pa? It is D minus X, right? Oh, sorry. This is D. So what is An is X, Bn is X, Pn is D. So what is AP? AP is D minus X, right? This whole thing is D. So this is AP is D minus X, and what is PB? D plus X, right? So it is D square minus X square. Say D square minus X square. Now say this is H. Okay. Now this is H. And what is, say this is R radius. So what is R square? A square minus X square. Sorry, A square plus X square. Right? Now if you replace X square here, then what happen? What will you get? If you replace X square, what will you get? D square plus A square minus R square, right? Right? But what is D square plus A square? It is actually OP square by Pythagoras theorem, right? This is D, Pn is D. Now this is H. So D square plus A square is OP square. No, so ultimately it is OP square minus R square. So this proof is as a extra advantage over the previous proof. Previous proof we just proved the product is equal to the other product, but here we do not take two line, we just take only one line, and we ultimately show that product is nothing but OP square minus R square. O is a fixed point, P is a fixed point, so OP is a fixed, R is also fixed. So whatever you line take, ultimately it will be OP square minus R square. So distance from the origin square minus radius square, right? Ultimately whatever the line, that actually in the proof P choice of A and B. So that means it is just everything is same. So AP into PB is same as PC into PD, whatever actually is same as OP square minus R square. See, if P is outside the circle, then OP is bigger greater than R, that's why it is positive. If it is inside, that's why you call it is negative, because then it is some negative number, because it is smaller, OP is smaller than R. And if it is on this circle, then is equal to 0. But for inside point, that proof is not like that, the proof will be, the diagram will be different. So it is again homework, this proof. So I give for inside, I give that proof, similarity proof. For outside, it is homework for using similarity, and using Pythagoras theorem we give the proof for the outside point, is homework to prove for the inside point using Pythagoras theorem. So that's all for today, and next day we will discuss on the some application of power of the point. We go into the circle. Okay.